Hello and welcome to Luckymath. The aim of this video is to introduce you to a handy tool when it comes to calculations with a logarithm. It's called the product rule and it goes as follows. Let's say we have the logarithm to any base a of some factors x1 times x2 times until we reach the last factor xn. Then this can be rewritten as the log to this same base a of the first factor x1 plus the log to base a of the second factor x2 and so on until we reach the last factor x3. If you've seen my earlier video up there, then you should know that the base a of any logarithm should always be real, but also positive and not equal to 1. Furthermore, the arguments x1 to xn, they should be real and positive because the logarithm can only take positive arguments, so the product of all these factors should be positive as well. So we have this second condition, and the subscript n should just be any natural integer number which is greater than 0. So for example 1, 2, 3, 4 and so on. So this is the general product rule for logarithms, and it basically states that the logarithm of a product of factors can be rewritten as the sum of the logarithms of all these factors. Now in your textbooks you mostly find the rule where n equals 2. So let's set n equal to 2. What we then get is the following. The log to any base a of x1 times x2, and then this is simply equal, by following this rule, to the log to base a of x1 plus the log of x2. Now, why is this a handy rule when it comes to calculations with a logarithm? Let's do an example. Suppose we have the logarithm to base 2 of, let's say, 6. Then 6 can be rewritten as 2 times 3, right? And then let's just simply use this product rule now, and we can rewrite this as the log to base 2 of the first factor 2 plus the log of the second factor 3. And what you notice is that the log to base 2 of 2 has to be 1 because 2 to the power 1 will equal 2. So now we can rewrite this logarithm simply as 1 plus log to base 2 of 3. So that's a simple example of how you can use this product rule. Now, one last thing for this video. Suppose all these factors were the same. Suppose x1 is equal to x2 is equal to the last factor xn, and let's just call all these factors, let's give them a value x. What happens? We would get the log to any base a of x times x times x and so on, so n times. Then this can simply be rewritten as the log to base a of x to the power n, right? Because we simply multiply x n times with itself. Now let's use the general product rule, and we can split this into the log to base a of the first factor x, plus, and so on, until the last factor x. So what we did, in fact, was simply adding n times the logarithm. So this is simply n times the log to base a of x. And this right here is another pretty cool rule. And so it basically states that you can simply take the power in the logarithm in front of the logarithm, and it is the same result. So let's do a simple example. Suppose we have the log to base 2 of 4 to the power 3, then this is simply 3 times the log to base 2 of 4. So I simply took this 3 in front of the logarithm, and this equals 2. 2 to the power 2 equals 4, and we get 6 as a result. In one of my next videos, I'm going to show you that this rule right here is actually called the power rule, and it doesn't only hold for n being an integer value which is greater than 0, but in fact it holds for all n being any real value. So you can look forward to that. Thanks for watching, rate the video, subscribe, and see you soon again on Lucky Math.